Hello, how are you? We're playing with the differences in the population thing. Yeah, let's talk about that and get you a little bit better prepared to tackle the differences in the population. So essentially, we have this code that grabs population data, and we need to know, hey, what is the largest difference in population? Well, let's make sure that we're grabbing our data. So I see in here that we got our populations. And we want to know what is the greatest and least difference or change between years of populations. We know we start 1950 here. So what we need to do is create another list called a differences list. So there's some challenges with that. And one of those challenges is when we parse and tokenize populations, because we're going to always have to look one ahead to subtract from the previous value of differences in the populations. So let me give you a better idea of kind of what I'm talking about. What we want is get your memory, print your memory. Very simple, guys. For I in range of length. We want the length of population. So we're doing this after we've grabbed the populations data from the file and verified it. And so I just want to print each population piece separately. So then I know that I'm ready to process it. So I'm going to do that. I'm going to print populations of I. And so that I know what each single population is. And I'm just going to verify that I'm able to do that. So let's do that because that's the start. Once we have the data, we can start manipulating. And it looks like we have the data now. So we're doing good. All right, now what we want is we want a differences list to do this. Diff equals, and it's going to be a list that we add when we are parsing populations. So what we'll do is populations has already been created. This is where you could do your average and stuff like that. We've already talked about that. But what we would do with the differences, we would say, hey, differences is equal to populations of I plus 1 minus populations of I. And you're probably looking at that and you're like, oh my God, that's too much, Mr. B. That's just, what the hell is that? Let's talk about it. And yeah, we're going squiggly. It's squiggly time. Let's see. Let's talk about what happens through all of this. And the line of code is we're going to be doing a for loop for I for I to size of populations. This is where you do the len of populations. So it's just the size of populations. So we start I2 and I goes all the way up to 1 less than the length or the size of populations. And so the first time through, we're going to be setting diff, and let's pretend what the populations list looks like. I'm going to use simple numbers here. So the populations list, let's say that it has this inside of it. Let's say that it has 6, 7, 9, 10, population, 11, 15. Very simple. It looks like the population is going up, but what year had the greatest increase in population is what we're trying to solve. So populations data where I is equal to 0, and this is I, guys. I is equal to 0. Populations is equal to 6. And I'm just making this number up for now because it's actually bigger in the file, but that's fine. We're just talking about it. So where populations is 7, let's say that that's at index 1. Populations is at 9. Let's say that's at index 2. Where populations is 10, that's at index 3. And now remember, this is I. And this is populations. Okay, so then at 4 and then 5. at those locations. So when we say difference is equal to populations, I'm going to use pop. I don't want to use populations because I don't want to write out that whole thing. Populations of, and this is where it gets a little nutty, I plus 1. Minus populations of I. Oh my God, where's my I? That's a horrible I. Okay, that's an I. Here. Let's put a little I in there so you know it's a little I. Okay, and then we'll squiggly. Oh my God. No. There. That's where I had somewhat of an I. There we go. That's better. All right, so that would be this is a minus. Minus. Okay. So the first time through the loop, when I starts at 0, we're saying take the population data of I plus 1. Well, if I is equal to 0, 0 plus 1, that means we're saying take the populations data of location 1 and subtract it from the population data, and since I is 0, of location 0. From location 0. So we're taking populations of 1, subtracting it from populations of 0. Well, what value does populations of 1 have? Well, if we look over here, 1 has the value 7. So that's going to come back as 7. And we're going to subtract that from populations of 0. In this case, I is 0, so that's 6. So then our first number on the list would be a population growth of 1. And then I runs again. So now I is equal to 1 in the loop, and I plus 1 is now referring to 2. And population of I is 1. So if we look at populations of 2, 0, 1, 2, now for the next one we're taking 9 minus populations of, in this case, I is 1. So when I is 1, it's going to be 1 right here. So it's populations of 2, 9, subtracting from populations of 1, which is 7. So then that difference is now going to be 2. And then that will go on the list, and then that will go on the new differences list. And we'll know that we just add 1950. I think there's a fence post there. We should add 1951 to it because look, we're looking one ahead. But we're going to have a problem with this. We're saying plus 1 here. That means that we have to run this loop is going to have a problem when we get to the end of the size of populations, because we're saying, hey, go to, when we get to the end in the loop of the population size, there is no I plus 1. So we have to do size of populations minus 1. Let me show you what I'm talking about. Okay, set a breakpoint right here. There we go. All right, so len of populations, good, great. We calculate the first difference. The first difference is going to be populations of I plus 1. We can actually add a watch for that. Let's just do Control C and then go over here and do Control V. Copy paste. Hit enter. So we know that that's that value, and we're going to subtract it from this value. Control C. The hell with it. Let's just look at diff. Well, diff is right here. Let's just look at that. Okay, let's do a step over. Okay, diff is equal to the first one. Then we go to the next one. There. Okay, so it looks like it's working. Okay, so then let's finish it out, and then we're going to have a problem. List index is out of range. Because we're doing this I plus 1, we're always looking one ahead, and we're doing it for length of populations. We need to fix that fence post and do it for length of populations minus 1. And then we also have another problem. Diff is being overwritten, and it's actually, this diff is not the same diff as our list. It's just a variable that's being created on the fly to hold that subtraction. So what we want to do is we want to actually add this difference to the list by appending it. And we append the return value of the calculation of populations of I plus 1 minus populations of I, which is the difference, which then goes on to the list. Okay, now we're going to look at it in the debugger and see what it's doing. Okay, now I'm going to do just continue here so I can see what's happening to diff. Continue diff, see diff is being created. It looks like all of those are working. And then when we play it out, we fix the fence post error. I think we fixed the fence post error. And then when we get done, we can print diff and it has all the different populations. So then to figure out, well, hey, what is the year with the maximum increase? To do that, you're not going to have line of code in the loop anymore. The loop is pretty much done. You got your data. Right here, now you're going to calculate max and min values and then get the index of those max and min values, and that's going to be your greatest increase. You got to add that to 1950. So let's just do a Python search, a quick search for Python max min index list. And it looks like we can do it with this code right here. So let's throw that in there. And remember, it's not going to be at the scope of, and you're probably going to want to call these different values, but the maximum value from the diff list is going to come up here. And then we're going to find the index, and that is going to be from the max value, and the list we're going to find the index of is diff. So what this is finding is the maximum value of the population change. What is the actual maximum value of the population change within the diff list? Okay, so it's going to return that maximum value. So we see here the maximum value right there is 3185 in the diff list. If we look at the diff list, 3185 is here. So I think this is 1951, 1952, 1953, 1954. I don't think we should say 1950. There's a fence post. Is it the greatest population growth afterwards? Because then I would want to add 1951, I think, for the fence post of the year. Because are we saying the biggest growth between 50 and 51? We should label that as 50 or 51. Common fence post issues. And it's often by interpretation. So in this case, I'm going to be exclusive and do 1951. So once we get the max index from the maximum value, what it can do is once it finds the maximum value, it can then go in and, hey, what is the index? Where is that located? And it's going to return 0, 1, 2, 3. It's going to return 4. And then we add that to 1951, 1951, and then we know that in 1955 or fence post 1954, we had the greatest population growth. I think my fence posts are correct on that, but it's up to interpretation in some ways, but in other ways it's not. So once we have the max index, let's look at that. What is that? Oh crap, it did not like me. Oh, populations is not defined. Why did it have a problem on max index for that? That is so odd. Yeah, this might be some formatting issues. What I don't know. Oh, it's just telling me it's not used. Okay, print. Max index. Okay. Yeah, it's going to be the index, which will be 4 plus 1951. And that's going to be the year of the greatest growth. Yeah, that should work. Did it work? Or does it not? It really does not like that. I don't know why. It's being stupid. I think it's just my stupid stuff. Let's go look at output. Okay, let's run it. Oh, looks like we do have a problem. Looks like run 190. That doesn't make any sense. Interesting. There we go, 1955. It came out. It looks like I'm just having issues with my debugger. That's all. I think we just set the breakpoint here and do the run a debug. There. 1955. Right there. There we go. Cool. All right, guys. Take care.